It's so similar to 10, you guys. I feel like you did this. Didn't we multiply something like 4i and distribute it in when we did 2, 9? Yeah, that's what we're doing. 4i times 2, that's 8i. And 4i times 6i, that's 24i squared. I know that's already going to throw some of you. I'm going to break it down on this one, all right? 4i times 2, 4 times 2 is 8. And then there's just one I, so it's just I. 4i times 6i. 4 times 6 is the 24, and I times I is I squared. So that's how that happens. And then now remember, when we see an I squared, we throw it out of there and we put in, what do we put in? -1. Remember always, I squared is -1. So this is -24 plus 8i. C. Okay. And number 2. That's a sneaky question. It looks like it's just one question. It's really 5 questions. So you got to simplify all of them to see which are equivalent to 32 plus 4i. Okay? I know. I feel the same. So distribute the 2. Distribute the -6i. So this is 2 plus 10i minus 6i minus 30i squared. Whoa, that just changed to red out of nowhere. So this is 2 plus 4i minus 30. Remember now that I squared is a -1. So look at that. Who would have thought it is 32 plus 4i? Yeah, it's not fun. Now we gotta do them all to really do this. This one is 4i plus 32i squared. Now I don't know if you've been catching on to a little pattern. Whenever I have a number I squared, since the I squared is -1, it just kind of becomes the opposite of the number. So -30i squared is +30. Let's go look at a different one. +24i squared, that's -24. You guys see it? So you could definitely save yourself some time if you catch these little patterns. If we look back at when we did 2, 9, here we had +24i squared, it became -24. Here we had +3i squared, it became -3. Okay, so let's go back. This +32i squared, that's going to be a -32, which means it is not going to match this expression of 32 plus 4i. Okay? It's not the same. Okay. Here I got to distribute the 4. I get 20 plus 4i minus 12i squared. That's 20 plus 4i. You guys, I'm going to start using this pattern. Minus 12i squared, that's +12. So this is 32 plus 4i. Okay. I feel I can leave you guys to try D and E and see if they are or they're not. I feel like you guys could do it. Because I wonder what else they've got up their sleeves. Honestly, they don't have much else up their sleeves. It's the same.
Isn't 2, 9 and 2, 10 like the same thing?
It's so similar. It's just doing operations with I. Just 2, 9 focuses more on adding and subtracting, but it does mix multiplication in, and 2, 10 focuses more on multiplying. But that also mixes in adding and subtracting. Okay. Here's a good one, number 3. Can anybody tell what number 3 wants you to do to 32 plus 4i? It's here, if you distribute, you get 32 plus 4i. What's the opposite of distributing? Factoring. It wants you to factor out a 2i. Wait a minute. I don't think that's, no, I take it back. I don't think we're there yet, you guys. I think it just wants you to think about what you could multiply 2i in here to get 32 plus 4i. I wonder how you would do this.
Couldn't you just look at B and then times everything in the parentheses by 2?
Oh, that's a good one. Yeah, I love that. Wait, no, but B didn't match. So if you adjusted B to match, then yes. Yeah, that would be good. Okay, here's what I'm thinking. I'm thinking let's go back to my original thought of factoring this. I think you guys can handle it. If we're factoring a 2i out, do you notice that they're factoring out a 2i? Remember that when you factor something out, what operation are you really doing? Yeah, you're dividing. So that means divide this by 2i and divide this by 2i. So we have 32 divided by 2i that we have to simplify. And then we also have 4i divided by 2i. Now 4i divided by 2i is a lot simpler because the i's cancel. And 4 divided by 2 is 2. Yeah. So the part of this parentheses here that does not have an I is 2. That's this part. Now the part that does have an I is going to have to come from this 32 over 2i business. Okay, I can go 32 divided by 2 is 16. So this is 16 divided by I. But that definitely is an A plus BI. We can't do that. But you remember with fractions, if you do something to the top and bottom, that's okay? So what if I multiply the top and the bottom by I? And the reason I want to do that is because I know I times I is -1, and it'll get rid of that weird fraction. Yeah, so on the top I have 16i, and on the bottom I have I times I, which is I squared. So this is 16i divided by -1, which is -16i. So the part of that parentheses that has an I is -16. Okay?
Wait, so, sorry, would it be a plus? Like, would you have to put that -16 parentheses then? Because you have the plus in the
You're right. Yeah. Technically, we wouldn't write plus minus like that. So you are totally right. Yeah. Yeah. I like that. Okay. And then problems 4, 5, and 6, I'm a little confused. Because I feel like it's just like the previous problems like 1 and 2. It's just 1 plus 5i times 1 plus 5i, distribute it. Or it's distribute the I into this thing. Or it's distribute the 9 and then distribute the 2i and then simplify and then replace your I squareds with -1. I don't really see. Yeah. Or they just really want you to do a whole lot of practice. I don't know. Do you guys want me to do one of them? Not really? 6? Sure. Let's do it. 9 times 3 is 27. 9 times -I, that's -9i. -2i times 3 is -6i. and negative 2i times negative I. Two negatives, now it's positive. 2i squared. So now here's what I'm going to do. I'm going to combine those like terms right there. And I'm going to simplify this part. So this is 27 minus 15i. And then if you remember the little pattern of what happens here, the I squared is negative 1 times the 2. So instead of a positive 2, I have a negative 2. This is 25 minus 15i. Number 6. Okay. Here are two expressions, a plus 2i and 4 plus bi. Determine the values of a and b so that the product of those two is a positive integer, or it only has imaginary parts. So again, this is the questions before the spiral review. It's the one you don't lose sleep over, but they are critical thinking questions. You guys, how many times have I said the rules of math don't change for funny looking? All right? I know this is funny looking that that's got an A in it instead of a number, and that that's got a B in it instead of a number. But they're talking to me about the product of two things, and we've been multiplying like crazy this whole time. You've been fine with that, so do the same. Okay? So take a plus 2i and take 4 plus bi and just multiply them. Distribute the a, distribute the 2i. This is 4a plus abi plus 8i plus 2bi squared. And then if I simplify this, these are my like terms because their I situation is the same. Okay? So this is a B. Lost it. Did it all wrong. Okay, here we go. You guys, when you look at this, I know it looks confusing, but you know that A and B represent just like numbers, right? So think of AB as a number. And if it's a number, let's say it's like 5. If you had 5i plus 8i, it would be 5 plus 8i, wouldn't it? You would add the 5 and the 8 and then the I. So, and then you would put the I. Well, it's not 5. It's AB. So this is AB plus 8i. And then this is 4a. And then over here, this is minus 2b right here. Because remember that I squared is negative 1, and it's going to change 2b to a negative 2b. And now, even though this doesn't look like it, 4a minus 2b, that's just a number. And ab plus 8i, that's just a number. So if I want this product to be a positive integer, that means I want this imaginary part to go away. I want AB plus 8 to be 0. Subtract the 8, subtract the 8. I want AB to be negative 8. So A and B, they can be like 2 and negative 4. But I got to pick them strategically so that this part comes out positive. Oh, actually, that's not good. 2 and 4, they kind of cancel out. Okay, it doesn't have to be 2 and 4. It can be like 8 and negative 1. If A is 8, this is 32. Minus 2 times negative 1 is definitely a positive number. That's 34. So A8, B negative 1. And then if I wanted to only have imaginary parts, I come back here, and then I want my 4a minus 2b to be 0. So I want 4a to equal 2b. So I just have to pick a number for a and b that works that way. Like a can be 3 and b can be 6. There's so many options that work. So that would be, that's what I'm gonna go with, 3 and 6. Okay, and then 9, 10, and 11, you guys, that's factoring. You could do that. I have a video on it that'll help you. Give it a try. Make your X, make your box. In this one, just take out the common factor. All good.